Good afternoon all. Next we are going to Newton's forward and backward interpolation formula. Before that we have to know what is interpolation and extrapolation. Consider a function y equal to f of x. Let x and y takes the following values x0, x1, x2, etc. xn, and the corresponding y values are y0, y1, y2, etc. yn. The process of finding a y value corresponding to an x value in the interval x0 and xn is called interpolation. The interpolation is the process of finding a missing y value corresponding to an x value in the interval x0 and xn. Extrapolation is the process of finding y value corresponding to an x value outside the interval. If the values of x are of equal width, that is the x values are x0, x0 plus h, x0 plus 2h, etc., we use Newton's forward and backward interpolation method. If x values are of unequal width, we use Lagrange's interpolation formula. We already discussed that. Next, Newton's forward interpolation formula. F of x0 plus nh. Here f of x0 plus nh means y value corresponding to the x value x0 plus nh is equal to f of x0 plus n into delta f of x0 plus n into n minus 1 by 2 factorial delta square f of x0 plus n into n minus 1 into n minus 2 by 3 factorial delta cube f of x0 plus etc. Here f of x0 can be denoted by y0, so we can rewrite the formula as y0 plus n into delta y0 plus n into n minus 1 by 2 factorial delta square y0 plus n into n minus 1 into n minus 2 by 3 factorial delta cube y0 plus etc. Here delta y0, delta square y0, delta cube y0 etc. are called forward difference. Delta y0 is the first forward difference, delta square y0 is the second forward difference, and so on. Next, Newton's backward interpolation formula. F of x0 minus nh is equal to y0 minus n into del y0 plus n into n minus 1 by 2 factorial del square y0 minus n into n minus 1 into n minus 2 by 3 factorial del cube y0 plus etc. Here del y0, del square y0, del cube y0 etc. are called backward difference. If x0 plus nh is near to the beginning of x value, we use forward interpolation formula. If x0 minus nh is near to the end value, we use backward interpolation formula. Next, forward difference table. The forward difference table, the first column is x values, second column y values, next column delta y. Delta y is called the first forward difference, and it is the difference between the y values. So delta y0 is equal to y1 minus y0, delta y1 is equal to y2 minus y1, delta y2 equal to y3 minus y2, etc. Next column delta square y, which is called the second forward difference and is obtained by the difference between the first forward difference. Delta square y0 is equal to delta y1 minus delta y0. Delta square y1 is equal to delta y2 minus delta y1, and so on. Delta cube y is the third forward difference, and it is the difference between the second forward difference values. Next, consider a problem. Using Newton's forward interpolation formula, find f of 1.6 from the following table. Here x values are given 1, 1.4, 1.8, 2.2. Y values are given 3.49, 4.82, 5.96, 6.5. Here the x values have equal width 1, 1.4. So here h is equal to 0.4 width. We have to find 1.6. Here 1.6 lies in the interval 1 and 2.2. We have to use Newton's forward interpolation formula. Given that x0 plus nh is equal to 1.6, here x0 equal to 1, h equal to 0.4. Substituting these values, we get n is equal to 1.5. Next, we have to draw the forward difference table. First column x value, second column y value, then third delta y. Delta y is the first forward difference, is the difference between the y values. So first 4.82 minus 3.49, 1.33. 5.96 minus 4.82, that is 1.14. 6.5 minus 5.96, that is 0.54. Next column delta square y. It is the difference between the delta y values. So 1.14 minus 1.133, that is minus 0.19. 0.54 minus 1.14, that is minus 0.6. Next column delta cube y. Minus 0.6 minus 0.19, that is minus 0.41. Last column contain only one value, so we can stop the table. Next, f of 1.6 is equal to, we can write the equation as y naught plus n into delta y naught plus n into n minus 1 by 2 factorial delta square y naught plus n into n minus 1 into n minus 2 by 3 factorial delta cube y naught. No remaining terms. So equal to, substitute all the values. Here y naught is the first value in the column y, and delta y naught is the first value in the column delta y. Delta square y naught is the first value in the column delta square y, and delta cube y naught is the first value in the column delta cube y. Substitute all these values and we get 5.4394 as answer.